So in this video I'm going to show you how can we do convolutional neural network for image recognition using Python, Keras and TensorFlow. So let's go. So first we'll start with some imports. So we are going to use NumPy. So we're going to import NumPy. From Keras models we're going to import sequential. We needed to create our model. From Keras layers, since we're gonna build the layers using Keras, so we're gonna import dense, dropout, flatten, batch normalization and activation. For convolutional network we're gonna import conv2d and max pooling 2d. We need also to import max norm from Keras constraints and np utils from keras.utils. In this tutorial we're going to use the data from CFAR10, so this is why we need to import it from Keras datasets. So the database in CFAR 10 it's already like it is like a big step of pre-processing that it's already done in this dataset. So it's gonna be in this tutorial we're gonna focus more in the convolutional network than dealing with the pre-processing of the data. So here I'm getting like the training and the distance data using the CFAR10.load data. So I'm gonna extract the data I'm gonna use to train my model and also to test my model. We can print the data so you can see just how the data is, how the images, it's all in the form of matrix. So like I said before, the data it's already pre-processed. So what I need to do, like for the training data and the testing data, I need to normalize the data, so the model only work with the data that is already normalized. So I'm gonna make all my data between the 0 and 1 so I can work with it in my model. So first I have to convert my data to float 32, and then to get this data between the range 0 and 1 I'm gonna divide all the data by 255. So in the neural network actually we have two categories of data. We have the input data and the output data. So the input data it's the X test and X train, and the output data or the data that we are looking for it from our model it's the Y train and the Y test. So I already did the pre-processing of the data for the input data, so I did the normalization, and for the output data I need to pre-process the data or use the one-hot encode. So since the data I'm expecting to get from my model it's supposed to be in kind of binary classification, so it's either like the data like it's a part of a class or not. I have only 0 or 1. And this is why I need to use the one-hot encode. And to use the one-hot encode, I use the command, the NumPy command, to categorical. So this is the function that let me get the encode or like encode our data so I can use it for binary classification. So here, yeah, you can see that I'm using the NP utils and then call the two categories, sorry, to encode my data. When we work with a neural network, it's very important to calculate the number of classes, and the number of classes means that how my data it's grouped by classes. So when I have a very large number of data or a large number of data sets, it's very important to group the data by classes, so it's going to be easier for me to know how many neurons to compress the final layer down to. So yeah, so this is why here we are calling the shape, so we can get all the classes of the data. Next step will be creating the model. So first we call sequential, and then we start to build the layer of the convolutional, and then and as you know, we are using the input and the output data, so we're gonna use both, use it to the input data or the X-train to train my model. So a neural network, when we use we create a model to scan or to for image classification, we use the we divide the image into filters. So each filter, it's a part, it means a part of the image. It's like we scan the image, and when we scan an image, we divide it into filter. So the number 32 here means the number of filters, and the tree it's then the size of the filters. Here we are using the conv2D. It's the function that we're going to use for convolutional neural network. I'm taking the X-train data, and the padding is going to be equal to same, which means we are not changing the size of the image at all. The activation function that I'm using here is the RULO. Next, we are making the dropout layer, and we use the dropout function to prevent the overfitting. So the dropout, we use it to eliminate some of the connection between the layers. So, and this way we prevent the overfitting. Next, we're gonna add the batch normalization, and the batch normalization, it's to normalize the input into the next layer. So we ensure that the network always creates activation with the same distribution. So we keep normalize the data every time between each layer. So next we're gonna have another and we're gonna create another layer. And then the size of the filter gonna be increased, so increased by double. Here I have 64, before it was 32, and now I increase it by double to 64. And the same thing, I'm gonna use the padding same, and the activation is gonna be RULO. Next, we'll create pooling layers, which means we will and like the CNN or the convolutional neural network, this layer we're gonna use it to abstract away the unnecessary parts of the image, keeping only the parts of the image the model things are relevant. So it's like it's gonna controlled by the specified size of the pooling layer. So we always so this gonna make our network more robust. So we're gonna keep just the data that we need instead of, or the information we need, instead of taking all the data and have a perfect model, but we're gonna have the overfitting. So it's better to extract only the data or the information we need from the neuron, and this is why we are using the max pooling. And again, we're gonna call the dropout and batch normalization. Now we can also always repeat these layers to give the network more representation to work off. So after finishing building all the layer of the network, we're gonna go to the last part, which is flattening the flatten step. So for the neuron or the convolutional neural network, the last step or the last layer needs the data to be flattened. So all the value should supposed to be compressed into a long vector, so the layer can take it and give us results or the output. Next is gonna be the dense layer. So it's the step when we prepare the model to get the output. So the number of the neurons here, we can see that it's duplicated. Again, it's to the 256. I'm gonna use the max norm because I needed to regularize the data, so which gonna prevent the overfitting. I'm gonna call the activation function Rulu, drop out again and do batch normalization and repeat the same thing, but in this time I'm gonna decrease the number of neurons, which gonna be the 128. In the last or the final layer, we will pass the number of classes for the number of neurons. It's the number of classes we calculated before. So each neuron represents a class. And yeah, so this is the last step we use this. So the output of this layer will be a 10 neuron vector, with each neuron storing some probability that the image in question belongs to the class it represents. I'm gonna also call the softmax activation function. So why I'm calling softmax, because this function gonna select the neuron with the highest probability as its output. So next we should select the epochs, because we need to train the data, and here I choose to be 25, and also the optimizer is gonna be Adam. Next I'm gonna compile the model. The loss gonna take the categorical cross entropy. The optimize gonna be optimizer, and the metric I'm gonna use here, it's gonna be the accuracy. And I'm gonna print just the summary so I can have all the information about the model. So here we get to train the model. So we're gonna call fits function and the model, and pass the chosen parameter. Here my data, like the data we choose, the X train, the Y train, and for validation data, the X test and the Y test, the number of epoch, and also the batch size. I also here I put a random seed, and this is just to ensure the reproducibility. So the training is gonna take a very long time, so I'm just gonna stop the video here and come back when I have all the results. So here, as you can see, like I finished all the training. I'm gonna go now and evaluate the model to see how it's performed. So we're gonna call the model evaluate. We're gonna use the testing data, the X test and the Y test, and we can print the accuracy percentage. Here, as you can see, I have 84% accuracy, which is really good for like a first run. We would probably want to play around with the model, so to see if we can like get more or like a better performance.